I would like to thank everyone that participate in another FMRI webinar. Today's webinar is co-hosted by WTS, Women Transportation Seminar at the FAU Student Chapter, and I'm very glad that they are participating really with energy on these webinars and help us to co-host the webinars. Today is my pleasure to introduce Dr. Manjeet Singh from DHL. That's a part of the operations science team which specialize in complex data analytics and mathematical modeling projects across DHL Global Center of Design Excellence. He has led the development of innovative advanced analytics tools and process for multiple warehouse.
So I'll begin with some background of the problems we are trying to tackle here. Then we'll get into different modules that are there within the tool called D3TO. And finally, within the modules, we'll also have few case studies, which will show how we used D3TO on actual problems and saved money for our customers. And finally, we'll look at the applicability all around, right? So let's look at the transportation problem first. So the way I see a transportation problem is basically looking at a series of demand that you have across a region. And what you try to do is try to find the lowest cost alternative to ship the parcels or the items from the warehouses to the final locations. This includes multiple sub-problems, right? You have, if you look at the overall bigger problem, the first problem that you are looking at is the network design, where you might look at where to put a particular warehouse, where to put a hub location where you would consolidate your shipments, right? And then once you have the locations assigned for a hub or for a warehouse, then you have to also assign customers around it. So that's your network design problem, basically, which looks at an overall picture for next 4, 5, 6 years, right? Because this includes a lot of costs that are going to incur if you make a decision based on putting a warehouse at a certain location or assigning certain customers to a given hub, right? So that's your bigger transportation problem. We call it network design. Then there is a sub problem called routing, basically, which you would see in almost all transportation problems. Whether you are doing a hub location problem, whether you are routing from a warehouse to your end customer, or you're routing from warehouse to another warehouse, or you're routing from a warehouse to intermediary smaller warehouses, right? So the routing assignment problem is basically taking multiple shipments and trying to find the best route of those shipments. And there are multiple methods to do that. You could tackle that using an IP, which is integer programming. You can use a heuristic. You can use a combination of the two, depending on how large the problem is. The third problem, which is very common in industry, is called freight rating, which is essentially based on the demand that you have across, let's say, a given region, for example, US. You try to figure out what percent of demand goes on what mode. And modes here being what percent should go in parcel, what percent should go with a common carrier, and what percent should go you do in-house. And when I say common carrier, my reference is, so DHL supply chain, basically, we are a 3PL. I'm assuming you guys are aware of what DHL supply chain does and our background. I didn't start with that considering we didn't have enough time. But basically what we do is we manage warehouses and transportations for various large companies. And when I say we manage transportation for these companies, what we do is we'll take the shipments that they have to do in, let's say, next 1 year under our control, and we'll figure out which of these shipments should we do ourselves with our own DHL fleet, and which shipments should we send to a common carrier or outsource it, right? Because we may not have enough capacity for all the shipments. And that's what we call mode optimization. It's really important part of the process because a lot of the cost is determined based on what level of volumes would you have in a given region versus a common carrier would have. The more volume you have or more density you have, the lower the price would be, right? So you have to figure out what modes make sense for what region and for how many deliveries do you have today versus what the projections are, right? Then there are a few other problems that we also tackle, which are more customized and specific to sometimes the customers. Sometimes it's specific to the situation. For example, if you have a large um, problem where you have a lot of deliveries which are going less than truckload or what we call LTL within US, uh, or even multi-stop truckloads, then you have to figure out combination of such deliveries which you could put on one trailer. Because if you could do that, and if you can start from one location and you can bring the truck back where most of the drive time is being utilized in making the deliveries, then you would actually have a really low cost solution. A lot of cost within US or even across the globe within transportation goes to the fact that you have trucks, you have smaller vehicles which make deliveries, they have to have some empty miles. You can't expect a truck or a trailer to always have load which needs to go to a customer on it, right? So if you can figure out combination of deliveries which you can put on one trailer, that would really reduce the cost, overall cost of your transportation spend, right? That's basically the overall transportation problem broken down into these separate sub-problems. The biggest issue that we have in general in transportation problem solving, and this is across the entire globe, I believe, is there is no tool as such which can deal with large data sets. You would find tools which are good with the execution on daily demands, which are good with 10,000 shipments, 20,000 shipments at max. But tools which can actually look at a 1 year worth of data, which could be, let's say, a million shipments, and give a really good solution in a quick time. I don't think anything like that exists today. And that was our basic problem we were trying to solve, is to get to a tool or to a software which can take into account a million shipments or more and give a strategic plan, basically, which can basically tell you what you need to do over next 30 days or half a year or 1 year, and then you can iteratively use that solution again and again or re-optimize that solution based on how the things change. But this is very important part of the process, because when DHL supply chain has to come up with a new solution for a new bid, for example, there are customers who would come up with like bids, and we have to come up with a solution for those bids. Then we have to give them a plan for whatever time horizon they'll give us. It could be a 1 year, it could be a 5 year time horizon, and that would be based on the sample data set they'll give us. That could be a year or 2 years worth of data, right? But it's really hard to actually do a good design for such a large data set without compromising on optimality somewhere. And that's what we'll try to go over today, how we used the tool we made to actually attack those problems and still reduce the amount of optimality we were losing, right? So how does a traditional transportation design process look like, right? As I said, when you are designing a transportation solution, an overall solution for a company, you would want approximately an year worth of data, right? So you start with your year worth of data, which could be a million shipments, let's say. Then the first thing any transportation analyst would do is figure out a good sample set, a good sample of 10 to 20 to 25,000 shipments, which he or she believes would be a representation of what's going to happen in near future, and also an average of let's say next 6 or 8 months, right? Then based on the problem we are trying to solve, are we trying to figure out um, the hub locations? Are we trying to figure out the routing decisions for these shipments where the hubs and the warehouse locations are fixed? Are we trying to figure out what um, percent of shipments should go to common carrier versus what should DHL do within? all this needs to be taken into consideration by the transportation analyst, and they need to determine which tool would they use. One tool would not do all of it, and if there is a tool which does multiple of these problems, they may not be, though that tool might not be as good in solving all these problems, right? So for example, you might use something like an Appian to figure out what fleet size you want to use, how many trucks to use for the routes you will do in-house. You'll use JDA to figure out whatever goes on common carrier or whatever you will outsource, how would you consolidate that demand? You'll use maybe a workway for routing optimization, and there are many more. If you guys look at the market, there'll be so many more of these tools for different problems I just mentioned. So now the transportation analyst has to figure out, based on this data set and the problem at hand, which of these tools they will start using, and in what sequence. And once you use that for, let's say, 10, 20,000 shipments, then you'll have to again resample some more from your data set, because just the 20,000 shipments might not do the trick for the overall data set. So you have to reiterate this solution again and again, multiple times, for multiple samples to have some confidence on your solution. Once you get the solution, after you go through these different tools for different aspects of transportation optimization, then you figure out which of these solutions are feasible. That's where humans come into play, because I have been asked multiple times, if we have tools which have really great optimization capability, which can look into a million records and give you a good decision to operationalize for next whatever time frame you are looking for, then why would you need a human being? You need a human being because there are so many practical aspects and operational aspects that even today, with all this intelligence, including AI, we cannot put into a machine. Someday in the future, I don't know, but today at least, what I know and what I understand is you still need to figure out, based on the solution that is given by tools, what you can operationalize, and in what way. And one simple example is, sometimes when you have a solution which gives you a route which shows uh, which shows you that you have to go from location A to location B via location C and D, and suddenly a news broke out that there is some political unrest. Now you have to understand that when you were doing this optimization, this news was not there. So now you have to sort of re-optimize, or at least make this solution that you have more feasible to your current condition, right? And it could also be a natural disaster. It could also be this traffic, because sometimes you did not take into account the traffic suddenly changed, and now you might have to do something on the fly, and optimization may not work that way, right? It's easier to rely on Google Maps for yourself, but when you're looking at an overall delivery schedule for a million shipments over next 1 year, you can't rely on an average solution that you get from Google Maps, right? So finally, once you do that, then the transportation analyst needs to create a proposal which would tell the customer that for your million shipments, I broke them down based on these segments. Now, segment A is 25% of deliveries, which needs to go with common carrier, or which we need to outsource. Second segment of 50% is going to go with DHL fleet, and this is the routes for that. And then there will be other optimization opportunities which I found, which are these, and I'll discuss those as well, right? And that's the proposal, and then you basically walk through how you got to those solutions, and what those savings mean in operational sense. Now, this whole process, what I described, can take a lot of time. And once you do it once, the customer might come back and say, I want you to tweak certain parts of your routes. I want you to change certain hubs because of preference, or because of some cost consideration that they understand, but we don't. And then the process has to be repeated again, which can take a lot of time. And then most of the companies, they do the design process like this, right? What we thought is, if we look at this problem, The biggest issue is we can't work with big data because that's why we have to iterate again and again, right? And this goes across for the entire transportation industry. Second issue is we are using multiple tools. There might be a format change for the data. There might be an issue with an output of one tool that could be an input of the second tool, but you're taking some time to figure it out, right? Data cleaning of any sense will take a lot of time. And then again, at the end, you have to do iterations after iterations, depending on A, the quality of solution you got, and B, even if you're happy with it, the feedback you'll get from the customers, right? So then the big question we are trying to solve, or which we I think we have solved to some extent, is how do you combine an expertise of a good transportation designer or an analyst and give them a good tool which can take big data, which in transportation is a million shipments, and actually give you a solution which is acceptable and has a near optimal solution which you can replicate again and again, given a short amount of time, right? Which can be used to come back with a solution within a day for a really large problem, right? So that's where our solution came into play. We developed this tool which we call D3TO, DHL Dynamic Decision Transportation Optimization, and it has various heuristics and various optimization routines within. In addition to all this, what it also has is a lot of nuances that people working in DHL for many, many years, they have seen. There are many really intelligent and very intuitive analysts, directors, senior directors, VPs, and transportation team who have actually seen multiple of these scenarios that where they have optimized for multiple regions within the US or even globally, and they have seen situations where we have to put in constraints which are not readily available in an off-the-shelf solution. So it's a combination of good mathematical heuristics and optimization techniques and the experience that we gained from discussing the problem over last many years with these folks, right? So now, how does the process look like now? You take the same 1 year worth of data. Now you pass it through D3TO because the difference is now you don't have to sample it because D3TO can handle the entire data set all at once. You use D3TO depending on the available time as many times iteratively as you want. And then what you do is you break down the solution into three parts. First thing the D3TO will do is create a benchmark solution for a current state. And then what it will show is it will show optimization of four types, which I'll discuss afterwards. One is called fleet optimization, then fleet, pool point optimization, round trip optimization. You do these routines, and afterwards, depending on the solution you get from this, you figure out what your corresponding savings are from the benchmark, and then you create a plan on how to operationalize this solution, right? And an output at the end would look like something like this, right? You went from the green bar all the way down to the blue bar, and whatever you have in between is your savings that came from these different routines, right? Another interesting aspect of D3TO is we've been working to develop a global version, and we are really getting really close to it. What we did is initially we took all the constraints and aspects of transportation networks within US, and based on that we developed the modules within D3TO. In this year, what we have also worked on and getting really close to completion is a global version of D3TO, which will take into account these constraints of routing, which are your LTL, less than truckload shipment rates, your truckload rates, your determination of different vehicles, what vehicle types to use in what situation, your constraints based on different road types, time of the day, all those aspects, and other risks you may have based on weather and all those things. In aggregate, you look at all those aspects, and what we try to do is we try to incorporate that in our current version and make it a global tool as opposed to just a US centric. So this is how the tool looks like, and why I'm showing you this before I get into the details of what the tool does is, if you guys in the future develop something on your own, one of the most important aspects to look forward to actually look into is how simple is the tool to work with. If you work with any off-the-shelf tool, what you'll find is it's not intuitive. There's a learning curve to this. You have to learn how to take out data. You have to learn how to import data. You have to learn how to go and find the particular button you are looking for to actually execute a certain part of optimization. If you want to play with the GUI in terms of what the visuals look like, there is even more complicated way to look at it. Almost all the softwares are like that, right? And there's a reason behind it, because none of the softwares were built by any 3PL like DHL, which had the knowledge of different aspects and how it would be utilized. And second part is, there are various methods to actually use this. So the off-the-shelf software are more generic in nature. What we uh, what we try to do here is to make the process as simple as possible, so that there is no learning curve as such. As long as you understand the problem, as long as you can have a clean data set to work with, this is going to be as simple as it gets, right? You work, if you look at the left hand side, something that says import, you click on import, it shows how to import the data. You click on shipment data, it shows you what you imported. Then you click on the module of D3TO you want to run. You can run all of them in sequential way. You can run one or two or whatever you want, right? And then this shows the different constraints you have for optimization. When you click on all these things, all it pops up is an Excel table where you can plug in the constraints. And as long as the formats match, there should not be an issue with the tool. And then at the end, it's as simple as just clicking run, and it will give you the output based on whatever you selected here, right? This is a snapshot of when one of our runs happened and it was done, right? And in this snapshot, it's saying that it ran. If I look at the output, it ran the freight result, it ran the pool point, it ran the round trip, and it did all of that in 179 seconds. Apparently, the data set was pretty small, and then you just click export, and it will give you all the output that you require. You take this output, and what we also have done is we have automated a process where we have combined our tool with Power BI and created these dashboards, which will give you results in a way you want to show to your customer, or you want to show to your internal stakeholders, or in your case, it could be your school, your projects, right? And all it does is takes the output from D3TO, puts it in the customized code that we have developed for visualizations in Power BI, and gives us different bar charts which show the benchmark state or the current state and the output state, and shows how the modes were changed. What was going LTL before is going TL, what was going parcel is now going LTL, and what are the hubs, what the transportation spend was, what is the difference now versus the benchmark, and all those aspects. And this image on the right top is one of the examples of such solutions we did, right? This might not be as important in terms of optimization, but since you guys will be doing this, either you guys are doing it already in your work or for your school, or you will be doing it in the future. Uh, Optimization opportunities driven by purely a software which is good at crunching numbers won't be enough to sell the product, won't be enough to actually operationalize. You have to have a buy-in from either your customers or the operations folks, right? And that only happens if you have a good visual, which shows how the determination of what you did, which is finding the right modes, finding the right hubs, finding the right routes, how is that actually working in different time horizons, and how is that actually saving you whatever amount. And it has to be shown in a way that is easy to interpret and also to verbalize, right? And that's why we did not create our own visuals in Excel or even Python. What we thought was Power BI was a great tool to do that, and you can program it however you like, and that's what basically we did. Okay. This slide shows the different you can call it algorithms and text that we used. So different algorithms that we used within the modules in D3TO are ant colony optimization. We used integer programming, and we also used genetic algorithms. In terms of performance, which was very critical in this case, because as I said, it's really hard to solve a routing problem with so many aspects within a reasonable time. And when you talk about a million shipments, it becomes exponentially harder, right? So we had to ensure we take into account any and every skill available to actually reduce the time. One of that is a part of computer science. And if you guys are aware of the two terms called multi-processing and multi-threading, we use those during our coding of the tool. For people who are not aware of what it means, I'll give a quick 2-minute overview. Multi-processing means if you have more than one core in your CPU, which most of us do nowadays, and in case of smarter or more powerful systems, you might have 8 or 16 or 20 cores or 32 cores, right? Each core is like a CPU. What you can do is if you can divide your problem into multiple segments. For example, if we have 1 year worth of data and we have to come up with this routing solution for each and every week, what we can do is we can divide this entire problem into week problems so it becomes a 52-week problem. And then you can, in theory, if you have 52 cores, you can put on those 52-week problems on the 52 cores in the same instant, right? And they'll be solved that way. The second aspect is called multi-threading, which means you take a problem and you use one core or one processor, but you break it into multiple steps. So each problem might have multiple steps. For example, the hub location problem, which is you try to find the hub where you want to consolidate your shipments, and then you ship the final mile from the hub to your customers and route it. So there are two problems here. First is finding the right hub, and second is routing from the hub to your customers. So if this was your total problem, you can break it into two segments and create two threads of the same problem. Step one would be done in thread one, and step two would be done in thread two on the same processor at the same time, which will again save time. So these two in conjunction would save you a lot of time. In terms of technology we use, basically, we coded the entire tool in Python, where we called a few routines from Groby and also used Google OR tools. Till now, I was talking about what this tool is all about, what problem we solve, and why did we even do this, right? Now let's get into some details of what the tools do, right? So D3TO has two main parts. One is the pre-processing engine, and second is the optimization modules. So basically, the pre-processing engine is just taking the data in, the standard data set, and checking to create a benchmark solution, a good benchmark solution, because the data set that comes in or that you get may not be clean and may not have a good standard benchmark. It might be really distorted. For example, it might have a load which is 15,000 pounds going parcel, which doesn't make sense. It has to go less than truckload. It has to go on a truck, right? Because it's 15,000 pounds. So those kind of mode optimizations, or I mean, we are using mode optimization, the term here, but it's more mode selection. The right mode selection, ensuring the right class of product of transportation is used. In the US, when you transport, the cost varies depending on the product as well. So different products are classified in different classes, and these classes and the weight and where you're going, which is a zip from where you start to the zip where you have to go. This whole combination has a separate rate for each and every of such permutations, right? And all that has to be taken into consideration when you create your benchmark process. So to ensure that you have the appropriate class for the product, appropriate weight has appropriate mode, and then that gives you your current state or your right benchmark solution, on which you will do optimization and reduce the cost and show that you have a better solution than the current benchmark, right? So you reach the benchmark by using the pre-processing engine, which has three parts. As I said, you benchmark cost, you figure out the right mode, and then you just combine the order consolidation is nothing but saying if you have multiple orders on the same day in your file and they were supposed to be combined into one load, and do that. So you basically do some cleaning of data to reach a good current data set. From then, what we have within the tool is 4 optimization modules, or 4 sub tools, you can call them. And they are freight optimization, which is trying to figure out the routes or the deliveries that will go multi-stop truckload one way, meaning the delivery starts from the warehouse. It's being done by a common carrier, not by, in this case, not by us, not by DHL. So the truck will start from the warehouse, but go one way, dropping different loads and end at a different location, right? And what the tool does is tries to figure out the best possible route so that you can combine certain deliveries to have lower cost. And you'll see an example. Fleet optimization is similar to freight optimization, but the difference is in fleet optimization, you take your own truck. In this case, DHL's own truck, but it could be some other company if there's some other 3PL, they have their own truck, right? So DHL's own truck, which starts at the warehouse, you try to figure out the routes for the deliveries that you want to combine, and you bring it back. So your deliveries have to be such that the truck has to come back, because the truck the housing position for the truck is your warehouse, the starting warehouse, right? Then you have the pool point optimization, which tells you for multiple of these less than truckload deliveries, can you combine them on a hub before you make the final delivery? And if you combine them, which hub locations would you use? Mostly people, when they use pool point logic, they'll come up with a hub location, which will be a static hub location for, let's say, next 6 months or 30 days. In reality, that's not optimal or even close to optimal solution. That what the problem actually requires is, because each day your volume changes based on the particular destination, or based on the customer or the product for a destination. So if the ratio of the product is different, or the volume is different on each destination or each delivery point, then ideally the hub location should not be same as well, right? It should move depending on where you have more and more deliveries and more volume. And that's why our tool, the difference between this tool versus what you will see is, this tool would try to find a hub location among the different hubs that you have allocated, a hub location for each and every day. The best hub location which makes sense for today, then the best hub location that makes sense for tomorrow, and so on. And finally, the fourth routine, or the fourth tool, is called round trip optimization, which basically takes the remaining deliveries that were one way and tries to combine them on one truck, as I mentioned in the first or second slide, right? Okay. Considering the time, I think I might not go in detail of all these tools, but if you guys have additional questions, I would like to answer during the Q&A. So the first module that what I discussed was freight module, and this is the module which, or the sub tool, which takes the deliveries and figures out what deliveries should be going to the common carrier, and in what, and which multi-stop one-way route should they do, which would be the lowest cost, right? And the inputs would be your different cost constraints, which would be based on the product, based on the weight, the time constraints, when does the delivery need to be there every day, right? Based on different distance thresholds, meaning if certain common carriers might say they don't want to go beyond 450 miles from the warehouse location, right? And they don't want to do, let's say, more than 2 or 3 drops. So all these constraints are a part of this. Then this is how, basically, if you were to visualize a blank problem, a problem that you are given to solve from a network optimization perspective, which includes everything in it, would look like this. You have 2 locations, and it's a simple example. 2 warehouse locations where the shipments would start from, and you have all these different delivery points, right? And the first thing we are trying to do in this case is use our freight tool to figure out one-way multi-stop routes. And let's see. So the tool, essentially what the tool is doing is trying to figure out multiple options of one-way multi-stop routes and trying to figure out which ones are the lowest cost. And when I say lowest cost, means if I were to use a less than truckload delivery with a common carrier, with somebody subcontracted to outside the company, can I save by doing this? Can I save by combining this and giving this delivery to a still a subcontractor, but combining this and making this into a truckload? So in this case, I combined this one, if you can see my cursor, and this one to one truck. It became a truckload, and instead of sending these two separately to one common carrier or two common carriers, now it became one truckload. And now I'll be charged differently now because I gave more volume, right? As opposed to a less than truckload volume. Lower volumes or less utilization of your truck is basically more cost. So you want to make more and more, you want to utilize your truck capacity more and more, right? So less than truckload means generally less than 50 to 60% of the overall capacity of the truckload is full. Truckload, whereas, is when you have more than 60% of your capacity full. And mostly, as you would think from common sense, is if you have more volume on your truck full, it would be more cost efficient, right? Because you have more goods being transported in the same truck on the same time. So this is telling me that these deliveries can be combined, these routes can be one-way multi-stop routes can be combined on one truck, and these could be given to the common carrier, right? Then what you do after this is you take out the ones you found, these deliveries that you found, and you move on to the next solution, which is for the remaining deliveries. Can I figure out routes which are closed loop, meaning they'll start at the warehouse but come back to the warehouse, and this gives me a closed loop route which I can put on my own fleet. And the constraints here are same as what we had before. The only difference is the resources that I have to use now, the capacity is going to be my own as opposed to a subcontractor, right? So in this case, after taking those out, now I'm trying to figure out deliveries I can put on my own truck, trying to figure out, and this is what this animation is showing is the heuristic is trying to figure out multiple iterations of multiple combinations, right? Which combinations would be the lowest cost possible. And in the previous module and this module, we used ant colony optimization. The only difference between the previous one and this one is the previous one was a hybrid method of a current ant colony optimization, whereas this one was a completely new ant colony optimization. People who don't know what this ant colony optimization does, it's basically there's a class of solutions called meta-heuristics. Meta-heuristics are basically solutions which take into account how normal processes around us take place and uses some aspects of that to find solutions using a mathematical equation which is closer to the process. In this case, we are trying to figure out a solution for routing based on how ants find food, right? So, and what we did is we took the basic logic of how ants find food and and created a new version of our own, which we call the red and black ant, and that was what we used to create these routes, right? And as I had mentioned before, we are using multi-processing and multi-threading in both freight module and fleet module, and that's helping us make this process faster, right? So basically, this is our second module. This shows an example. I won't go in detail in the interest of time. This is an example of where we implemented this module, and this is showing that for 1 week, if you look at this graph on top right, for 1 week, the black is where we started, the benchmark. The yellow is where we ended up in our solution. So for 1 week, we can save 25K, right? And you multiply that with this average number with your 52 weeks, and that's your yearly savings for this customer, right? And it shows the different routes that the solution showed, that the D3TO solution came back with, right? Sorry. And then the third solution, if you were to do this whole process iteratively and in a good sequence, this is the sequence you will do it in. You will first use the freight module to figure out what goes on a common carrier, the multi-stop one-way routes. Then you will figure out the the fleet module, what goes on your own trucks and the round trips. and then you will look at the pool point module. What you're doing each time is, if you find a really good solution or near optimal solution, you take out those deliveries. And each time you're reducing the size of your problem, right? Now you're left with your one-way, your LTL shipments, your less than truckload shipments, which were to go to a common carrier if you were not to do any other optimization, right? Now you will take those shipments and you'll try to figure out a good hub location. And I have a different animation to show how that works, actually. So from the warehouse, sorry. So you have the warehouse, you have these customers. This is showing that if the current state is you just find the current cost, right? If everything were to go LTL, then what would the tool do? The tool would figure out a couple of pool points. Then based on it'll assign the deliveries to a pool point, the combination of deliveries to pool point 1 and pool point 2. Then it'll do it iteratively again and again by figuring out different combination of deliveries for different pool points to find the lowest cost. And finally, it will assign the pool point and the corresponding deliveries, right? This is the basic concept, but if you were to use the same concept for the problem we have been solving till now, for this problem, you found these pool points and this is the solution, right? So now you've these deliveries here. Now these will be again taken out because you have found the optimization or the right optimal solution for these deliveries, and whatever you are left with, those and the deliveries that were in your first couple of modules, those would be taken into account in our next module. So for this module, this is one of our implementations as well, where we use the tool to actually figure out daily pool points for one of our customers, which in the Midwest, and the pool points it gave for that particular week, which we are looking at right now, is near Columbus. There's a place called Groveport and Knoxville, Tennessee, and you use these tools, these two hub locations iteratively for that week, and you'll end up saving around 48K, right? Okay, one more quick thing I want to notice here. If you look at this particular image, it says that everything in the benchmark state, most of it was going LTL, and very minute percent was truckload, which is going to be efficient. But then after the solution, everything is going through the pool, and it's much more efficient, right? Because they're combining the deliveries on one truck. Finally, the last module is called round trip. Again, let me quickly show you guys an animation which shows the basic concept. You have delivery going from Dallas to Chicago, right? You have delivery coming back from Lafayette to Fairfield. If, one second, sorry. Think. Okay, so you have delivery going from Dallas to Chicago. What this is saying is you have that delivery, but if you don't optimize, there's a chance that you might have a lot of empty miles coming back on the same trailer. But if you look at a large data set and you find other deliveries, in this example, if you find another delivery coming back from a nearby region, in this case, back from Lafayette to Fairfield, and if you can combine this thing in one truck, these two deliveries on one truck, then you can essentially bring back the same truck to the original location with minimal empty miles. These dotted lines are the empty miles. And what the tool does is looks at a larger data set where you have these deliveries going to different locations, one-way deliveries, and try to combine them as much as possible, depending on the time horizon and the locations, on one truck and try to reduce the cost, right? And if you look at our previous example, that means that we'll take the deliveries that we used in our first tool, which was one-way multi-stop routes, and the remaining deliveries that we couldn't optimize, and try to combine them if we can, right? So the black ones are the remaining deliveries. The red ones are what we optimized in our first tool for our common carriers. And now what we'll do is we'll try to combine them. And this yellow route just popped up. That was one such combination, right? And it's going to try multiple iterations like that and try to find the ones which make sense. And in this case, it says, okay, this is my final solution, right? So it found this combination of route which you can put on one truck. How this helps is even if these deliveries are being done by common carrier, still by giving them a route like this, which reduces empty miles, you can actually negotiate a better price, right? And again, for this solution as well, we use multi-threading, multi-processing. We used Google OR tools in this case, and at the end, once you're done with this, you're left with very few deliveries, which left unoptimized, which will be going less than truckload to a common carrier with whatever price they want, right? Everything else we have done so far, we have optimized and tried to find the lowest cost solution, which could, even if you do it with a common carrier or outsource, or you do it yourself. Try to combine as much as possible to create those truckloads, create those opportunities, reduce cost, right? And a quick example is with this case study or this application shows using all the modules. We used all the modules on a 1 week shipment data set. Sorry, so this was a 6 month shipment data set with around 20K shipments. And if you look at the solution, this is showing you that the current state solution, if you look at the right hand side bottom chart, the current cost was around 12.1 million for the year, and this with the solution you would go down to around 10.5, right? So you would save around $2 million with this. I think we can leave this slide considering the time. All this slide is saying is we can use this tool in 4 different ways. We can use it to design a new solution for a new customer. We can re-engineer a current solution, make it better. We can even execute in certain cases if we use our round trip. Sorry, if we use our first couple of modules, which are the freight module and the fleet module, we can use it every day to find the best combination of trips to give to a common carrier or to give or to put on a DHL freight. And finally, number 4 says that right now we are looking at trying to figure out a solution which can help us create a communications API between this software and existing management solutions that are there in the market, right? I think I'm done. So let's do the Q&A now. Thank you.
All right, thank you, Dr. Singh. Thank you for presenting about this project, and it's really interesting. And I really believed in this approach of automatically integrating processes, eliminating manual operations of successive steps, creating decision support systems. And if you do something over and over, then automating it is truly the best solution. And it also creates room for more optimized work and focusing on other aspects that would not get as much attention. We are now open for questions, and I will start with the first question. You mentioned optimization, big data, and big data can provide a multitude of insights. Do you use any deep learning methods from the data inputs and results to optimize the results even more in future runs?
I have done a few research projects on within warehousing and transportation industry, which look into some patterns in our solutions in the data sets, which could be utilized further. But to be frank with you, the industry itself still needs to use optimization first. There's a lot of opportunity to use big data with just pure optimization. And when you know the deliveries, for example, the problem is that I know what's going to happen in the next 6 months. All I need to now is to have a good optimization routine, which can take this 6 months of worth of deliveries and give me some solution which is acceptable fast. So we are at that stage first as an industry. Machine learning is really good to identify patterns, but you have to have the descriptive analytics done first before you go, jump into something more robust. But yeah, I have looked into it, and I'm sure there are opportunities available there. And in the near future, we will see a combination of machine learning and optimization routines working alongside. Machine learning would make more sense in predictive analytics, in my opinion, than descriptive.
Mm-hmm. And you also mentioned that the attributes for this application are applied to the US transportation marketplace. And do you see a possibility for this tool to get a more global applicability, integration with different markets from different countries? And if yes, do you see any benefits for this more globalized solution?
As I said during the presentation, we already are working on creating a global solution. And in next couple of months, we'll be done with our global rollout. So DHL is present everywhere, and we have partners in all the regions: Asia Pacific, Europe, Africa, Latin America. And we have researched all their constraints and what is the difference between what they do and what happens in the US in terms of different freight classes, different vehicle types, road constraints, routing constraints, and we are getting to a point where we'll have that solution. And yes, it is going to be applicable everywhere, because routing from a mathematical perspective and finding hub locations and round trip solutions are global in nature. You see these problems everywhere, right? The only thing is we have to ensure that we incorporate these constraints very well to make the solution acceptable in a practical environment, right?
Mhm. We have one question in the chat if this work is published.
Yes, we have. The work I have published is very theoretical, though. There is one paper I have published, I think it was early this year, in what was the journal? Um,
I think it was
was jour-
Informs.
yes, Informs Journal of Applied Analytics or something like that. And then we are working on a couple of more papers on the same solution, which would be coming out soon. So I can share the link of the paper, or I can even share the paper with you guys, and you can take a look.
Mhm. There are
But that only considers one of the tools or one of the processes. This has four. We only look at the first two.
Mhm.
Yeah.
All right, thank you. There are questions if this tool is being used across DHL and if any other company is using this solution and if the tool is available to the public.
Right now, it's being used in North America, and as I said, the global version is going to roll out soon. So people are going to start. The transportation analysts and the transportation design departments across the globe will start using within DHL. At this point, the management has made the decision not to make it available to customers outside DHL's portfolio. So it's an DHL IP. We have filed for a patent as well, and we want to keep it niche for now. Maybe in the future we might use only this as a solution we want to sell, but at this point it comes only to our customers. Because when I say our customers, I mean the customers we manage the transportation for.
Mhm. We have one last question from Frank. He's saying that DHL collects its routing data. Is this data available to public DOTs?
Uh, Most of the times, no, because customers are not uh, as accepting of this till now. I don't know what the future holds, but it's hard to share customer data outside unless there is a specific project which is important for a customer and we take the permission and give it to somebody outside. It's available to us to research and do what we did, but to give it to somebody outside, we have to have special permission from those guys because the data belongs to them, not to us.
Mhm. All right. Thank you. It was a great discussion. Thank you all for the questions. And I think we can conclude this session. And on behalf of the Freight Mobility Research Institute and the WTS FAU student chapter, we would like to thank you, Dr. Singh, for presenting to us today. And it was a great discussion. Thank you all for joining us for this presentation.
Thanks, Aline. Thanks, everybody. I hope all this made sense. And if there's any other additional questions, would be happy to answer through emails or any other medium. Thank you.